Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Reflect Orbital. So let's dive deep into it. So what's the idea? Idea is very simple. You're going to put mirrors in orbit. That's from their website. Do not ask me. That's from their website. And the idea is that this is going to unlock the ability for solar farm to make electricity at night. Right now, humanity is going YOLO on solar, and solar is amazing. It has very quick ROI and provides bonkersly large amount of power. So everything is there. It's just the moment sun goes down, this is like I'm out. So what if it's not out? So that's the way to unlock. Basically, we already have the solar farm. We are already investing into this. This is already physically existing. What if we can increase its duration? Specifically, if evening duration. If you can increase the evening duration by 2 to 4 hours, you're done, you're sorted. That duck curve has ludicrously high drain the moment people come from office. So if we can flatten out that duck curve, majority of humanity's problem would be solved. So there's a very good demand for it. And idea is extending the work time of solar farm. So solar farm has an activation period. Basically, let's say it works for 6 to 8 hours per day. What if it's instead of that, it stretches to 11 or 12 hours per day? Now 24 hours per day, that will require way too much orbital infrastructure, but in principle it's doable, but they are not targeting that. Everybody is targeting just to expand it, like, bit early. That will sort almost all the problems. So that's the aim of it. So the idea is, or that's what you're going to do. Or you can order a spotlight, meaning you can open your phone, plonk a number, basically your coordinate, and pay for it, and you can get spotlight of sunlight in where you are. And this spotlight would be kind of almost like how you see a torch in long distance. It will be like that, and it would be a 5 square kilometer area. So that's there. And can this be done? Like in principle, yeah, absolutely. Like, oh, you have solar farm, you can reflect light from, let's say, the other side of the sun's solar side of the earth, dump it into the shade side, problem solved. Can this work? Absolutely. Then why didn't we do that? Well, we did not have the access to space. There is no company other than SpaceX that could even allow you to think like that. There is nothing. Let that be very clear. There is nothing. There is no China. There is no America. There is no ULA. There is nothing that has the same cadence and same horsepower and same capability that can match what SpaceX is doing. Nothing. And on top of that, so this company is very clear. It's like what SpaceX has is mind-boggling, but they're not betting on that. They're not betting to build that orbital infrastructure based on that. They are betting on Starship. Now let me be very clear. Elon Musk, he smokes too much, so his timeline is lol. So if he says that will be done in 2 years, you take 2 years, multiply that by a cube, so let's say 6 to 7 years it will be done. But it will be done. That's the good part. Bad part is timelines are lol. So it will be done. So that's what they are aiming for. They know for a fact they can test it, they can deploy the systems and have some demos and all that. Early round of seed funding can be done with that, but to actually pump out money, they do need this bus to be ready. For example, in contrast, this is a bus and Falcon 9 is a taxi, so they need a bus service. So that's the idea of it. This unlocks this sort of crazy idea. Before this, we had this idea. We had this from 1950s. It's just that nobody bothered to do it simply because, again, there is no way to get it cheaply enough in space. That has been changed, and that is factual. So is there a history to this? Yes, absolutely. Zamir, that was one project, this puppy. And yes, this is the real footage, not doctored. This is from Mir space station, not ISS, Mir space station. That's why there is a footage. And it was done by Vladimir Chernovsky. I'm sorry, I cannot pronunciate his name, but this individual is a very high caliber individual because he's the one responsible for docking clamps of Soviet Union. And yes, that's the docking clamp that is used still today in, basically ISS. So very capable individual, knows his stuff. Now he did not wanted to build solar reflector. What he wanted to build was solar sail. That was his passion project. He wanted to do deep space exploration on solar sails. And again, very clever individual, and he knows what he was talking about. But here still, he could not get funding for it. This is Soviet Union era. So he was like, he applied chocolate milk strategy. So if you do not know chocolate milk strategy, the idea is that to parents, you sell it's a milk, it's good for your boy. To the boy, you sell it's a chocolate, enjoy. So that's what we call chocolate milk. So he did that. Okay, I want solar cell. That's what I want. But you guys, Soviet Union, dictatorship, you want more production. Now, because they are very close to equator, very close to North Pole, they do have very long nights. And in winter, it becomes brutal. And because they did not have good enough infrastructure in terms of electricity, very early days, they were bad. Like, it was was bad. So they were like, street lights are expensive luxuries. They did not have the luxury to have that everywhere. So like, what if we can use space? You deploy the money in one rocket and you can have spotlight everywhere. So the idea was there, and people worked onto it. A lot of people poured their own money into it because the idea was so compelling to Soviet Union that what if farmers' productivity could be increased for a few more hours. Now, they were not expecting like full daylight. Let that be very clear. They were not expecting that. Their aim was that we could have enough light that bulk work could be done. Meaning you can move, you're not going to be able to read and write. Maybe you can read and write like large fonts, but not small, but it would be like 2x or 3x of maximum lunar luminance. If they could achieve that, that would make it viable. Like you can navigate, you can move around, you can do things. Basically, you can be productive in long winter nights. That was the aim. So that was sold to Soviet Union. That was the chocolate sold to Soviet Union, and he wanted the milk of solar cell. So that's how this project got started. So they did make version number 1. It was a land test. It worked. Then they made version 2, this puppy. Now, because this was a prototype, quote unquote, they did not build a craft for this one. They were like, okay, you are going for Mir space station. Let's put it into the trunk, quote unquote, and then we're going to test it out. So they did it. It worked. And because it was not a dedicated hardware, they did not have controlling algorithm, meaning they could unlock it. That's it. They cannot aim it. There was no thrusters and arm mechanism designed to actually aim it. That was not even the intent. The intent was they figured out the orbitals. They figured out if the timings is just right, we can have it in such a way that it's going to have a basically solar flare kind of, not even flare, satellite flare, where it's going to go around hemispheres. It did cross Soviet Union, it did cross Europe also, but unfortunately when this actually happened, there was cloudy morning, so they could not actually see it. But other places did notice it, and the places that were in that spotlight, that spot that they were reflecting to, it was like said that it did feel like exactly like a full brightness of moon. So moonless night can be turned into mooned night with this. And this was a small scale prototype. So they did this. It worked. Everything is fine. Then they tried to launch a bigger one. And again, that would have been exponentially bigger than this one. And they did. Unfortunately, command was messed up. So instead of commanding the antenna deploy, then sail deploy, it was still deploying. The antenna was deployed. Antenna tore it apart. So it distracted. After that, when Putin came into power, he did not have enough money. So they are like, okay, the project was cancelled. Basically, it was a very clever way of getting something done out of what he wanted to do. What he wanted to do was a lot of research in solar cell, which is a clever idea, and there is no discussion about it. Very good that he was planning to for that, but he had to sell it. So that's what happened. But after that, project was like permanently canned. So very competent gentleman. And his deal, this idea is very attractive to dictatorship. So China, of course, China also went into this. And if you have been watching my channel for a few years, you would have known in 2018, China also started to, it's like, what if we can have this? And I'm not joking, this is in their official record. Costly street lights operation can be reduced if we hand spotlights from basically orbit that is illuminating the whole area. Now, can this be done? Let this be very clear. Can this be done? Illumination from space using orbital assets? Absolutely. Why? Well, moon reflects a lot of light. Moon is a large surface area, but also it's 1 light second away from us. It's more than 300,000 kilometers away from us, while low Earth orbit is barely 300 to 500 kilometers, barely. So you are very close to us. So that helps a lot. Another aspect is the best case scenario lunar surface is that it's a 20% albedo, meaning 100% falls into it, only 20% gets reflected. These sort of mylar sheets, these puppy can touch 99%. So not only your reflection efficiency and the fact that you are so close to the target, it improves that odd of this working. And our eyes are ludicrously sensitive to basically low enough illumination. Like once our pupil goes yellow, we can see like damn near in darkness. And given the fact full night is like, you can do things. If you have a full moon out, you can do things. And they were targeting 2x or 3x. So that was the idea with China. Is like, okay, they also have remote location. Again, they also have things that are very close to North Pole. They're like, what if we do that? It's like, okay, they tried it. This was in 2018. And I have no idea what happened. They were actually supposed to launch it by 2022. I have never seen or heard about this project ever again. If you know, please do tell me, but that was the aim. And could it have been done? Absolutely. It would have destroyed the biology, specifically of insects, so pollination, bye-bye, bird, bye-bye, migrative, and bye-bye. So it's going to have devastating consequences, especially on the size that they were actually planning to do. Not this one, like minor inconvenience, or the big ones that they were actually trying to do, that would have had serious consequences. And like consequences so large, like it could have affected children, as in like children would have aged much quicker. because again, how does our body know how old we are? It just have an on-off switch based on our eye. Basically, light comes on, turn on the valve. When do you turn off the valve? When you go to sleep, turn off. Now, back in the days, because we did not have artificial lighting, it was tied to the clocks of the sun. Now we have artificial lighting, so a child could literally be, that's why children are looks like so adult so early. It's because again, from our point of view, they used to be 12 hours a day. Now it's 18 hours a day. They are so surrounded by lights. So if you have a freaking outside also like illuminated, it would have consequences. Now, subtle, again, it's not like, life or death, but it would have caused effect on us, and in small animals, they would have been poofed. So this was the history of this sort of idea. Now, refractable orbital. Now, it's a group of talented people somehow. This is the group, and all fields. There are surprisingly large amount of fields from optics, from heliosats, and all that. There are a lot of people working into this. Now, Ben Novacom is the CEO, and his claim to fame is that he worked in SpaceX. Now, let's be very clear. He worked as an unpaid intern in SpaceX, which I am kind of confused that SpaceX has unpaid intern, but that's what he did. And there is that's his claim to fame, that I worked at SpaceX. Another is Trisman Semelhak. Sorry about that. I am very bad with names. And he made Zipline Drone Company, the drone delivery services and all that. So, and again, if you do not heard about it, that's not very popular or successful. So these two got together and they are building this. Now, there are far more talented people, including an Indian also for some reason. So is there. Now, media interest, like this idea, has been brewing in the background for years, and they had funding and all that. So the first time people started to notice this was in 2022. And now they are in the fundraising partner, like, wait a minute, they had funding, they were in publications, basically they had funding for this puppy, they did it. This is a hot air balloon testing, and this is how to show that what they're thinking about, what they are doing is actually viable. And basically it's a prototype. So they had an idea, they worked on the idea, then they built a prototype with the money they had, and now showing this prototype, they are trying to do basically in-orbit demonstration. They want to launch something like a CubeSat in Falcon 9 to actually have a shot. Like that's their aim. So that's what they are doing right now in 2024. So let me be very blunt here. Nope. Will this work? Nope. So let me be like, why is that? Well, law of physics is clear. It will not work. Why it will not work? Because this is the demo that they are showing. It's like, cool, awesome. Now, it's invalid test. Why? The biggest issue is the distance, and that's the thing that is missing. For example, if I show you this camera remote, this is a very cheap Amazon basic camera remote. I'm using this to control this camera. Cool, I can turn it on and off. Awesome, normal, you know this. You may even have a television report like this. It's a normal, right? I can do it, control it, everything fine. Here's the deal, if I tell you the same thing, right? I can use the same remote and have this camera 500 meters away, 2 kilometers, a line of sight, 200 meters away. Would that work? Most of you will have like press X for doubt. If I said it was like 10 kilometers away, you will say, yeah, likelihood of that working is 0. That's the whole point. If something works at 1 kilometer, does not mean it magically works in like freaking, 200 kilometers. So that is bare minimum, by the way. 200 kilometers, it will be higher than that. So yeah, that's the problem. It's like they literally bypass the most crucial aspect. If they were doing even a high altitude balloon test where it was like 30 kilometers up, they would have like lost interest in all of that. And maybe they knew, because I do not know whether these people are like lost into something or they're actually trying to scam. I do not know which one is true. So this whole idea, like they have like lux meters and all that, cool, at 1 kilometer, barely 1 kilometer, it would work. And again, hot air balloons go very high up. It was not very high up. If they were testing with weather balloons that can actually go to almost stratosphere of like 30 kilometers and all that, then I was like, okay. And again, at that point, I know for a fact they're like, yeah, it does not work the way I expect. It's like, that's the whole point of radio communication. It's like super easy. Oh, I have a radio communication. Any Tom, Dick and Harry can do that in their household. Now make a radio communication that works from here to low Earth orbit. People are like, whoa, that's the whole point. So can it be done for illumination? Absolutely. We have the data, we have the telemetry. We know it works for human eye illumination, because these puppies are sensitive as hell. And again, you can achieve 2x or 4x of the illumination. Not this one is too small. What Russians were planning in the version 3 and version 4, they could have done that. And even in China's planned system could have done that. It's nothing outlandish. But here's the deal. To run solar farm, like this idea, like you're going to have the spotlight and the spotlight is going to fall on solar farm and you're going to get electricity out of it. Let's come to real world. If you ever looked into a solar panel, all solar panels will say 1000 watt per meter square. That's their minimum rating for like actual standard. Like when you say like 600 watt plate or 700 watt plate, what does that mean? That simply means if you have this sort of radiance, 1000 watt per meter, you should get that kind of power output. Cool. What happens? That radiance goes down, right? Again, weather goes down, cloud and all that power goes down. Normal. What happens if you go above the atmosphere, right? Now above the atmosphere you get 1300 watts. So you were like, okay, problem solved. We have 1000 on the ground and we have 1300 in space. We are reflecting from the space. We problem solved. Yeah, no, because unless you have magical teleportation where it's like, okay, I collect the sunlight and magically beam it to without any physics. If you reflect it, it still has to go through the atmosphere. Still has to go through 100 kilometers of thick, turbulent atmosphere. It's gonna lose that exact amount. That's why it is that. If it was like, there is nothing magical there. That's the property of the atmosphere. If you have to go through the atmosphere, you will lose that amount. So 1300 watt per meter square will drop to 1000. Now, so far, that's minor inconvenience, right? Oh, we had 13, like, but we're still getting 1000. Yeah. Yes, that's why, again, it goes back to distance. Is that the spread, that inverse square law, like, and you're like, it's a mirror, okay? It has inverse square law. It's not a laser. Even lasers at that sort of distance starts to spread out, let alone just a mirror. And even like parabolic and all that, none of them will work. They are talking about flat mirrors. Their renders are flat mirror. The calculations are on flat mirror. So I'm talking about flat mirror. No parabola and all that, and nothing works that well for 200 or 300 kilometers away. So it will go through the atmosphere. It will spread. Now here's the deal. When you are actually making a mirror that is 100 meters square, that's the surface area. That's what they are talking about. Not me. That's what they are talking about. When it actually tries to, like, fire a beam 200 kilometers down, the surface area goes from 100 meters square to 19.6 kilometers square. It's not even in the same unit. It's no longer in meters. It's in kilometers. Now you stretch whatever the power you had, whatever, like let's say you took 1300 watt per meter square, you multiplied that with 100 meter square. Now you divide by this glow point, this glower, like distribution, dilution, so to say. Yeah, at that point it's microwatts. It's useless. It's so little power that it's generally said that you need bare minimum 200 to 300 watt per meter square in order for solar panel to start working. At very low photon flux, it will not work, especially the panels that we use for, power plants. The panels that we use for watches and calculators, those amorphous solar structures, those are very sensitive. They might work at very low powers, but generally the plates that you see, the blue color one, the dark blue and black ones, they will not. The brown one, it could work. But again, even that will also require 50 minimum. This will give you microwatt. It cannot even start the inverter. It will not have enough oomph. The photons will not have enough oomph for electron flow to happen. And even if somehow you have ultra sensitive cells, it will not have enough juice to actually start the inverter. Inverter will not even boot up. So fundamentally, and again, we know this. How do we know this? We have moon. We have the moon. The moon goes through solar farms a lot of times. And at that point in time, nothing happens. No power, nothing, zero, zilch, nothing. So this is the whole point. It's like, it's not going to work for power. Like again, this spotlight now, can this spotlight principle work? No. Anytime you're talking about a whole block will be illuminated. You have to get license from that. Again, police can do that. Like if they are doing search and rescue in some remote area, I could see that working. And I'm stretching way too thin. Other than that, I could not even find. Maybe if you're Jeff Bezos, you own a freaking ranch that is hundreds of square kilometers, maybe. But practically speaking, it's not gonna work for anything. Like think about it, at what point it's valuable. And if you really need that sort of illumination, like they're talking like, what if we want to do a sci-fi movie, we want light from the space, it's like hire a helicopter or rent a big drone. There are some drones that can carry kilograms of payload. At the kilograms of payload, you can have a big ass generator and a big ass LED. You're good. You will actually get more luminance out of that than this. So fundamentally, and this is how I know that he was just an intern. He said like his first prototypes will targeted life is 10 years. 10 years in low Earth orbit is not possible. Now still, why not? We have things like we have ISS. ISS requires reboosting almost annually, sometimes 2 times a year. It had to be boosted. Basically, SpaceX whole constellation that is in low Earth orbit, those puppies have ion thrusters, and they are designed in such a way that if the thrusters malfunction, it crashes and burns into the atmosphere. No more space junk. Yeah, you're not gonna stay in space. Now here's the, there is two ways you can improve your odds. First, you make your satellite dense, meaning you have solar panel, cool, but everything else is in dense. Basically, you want density. You want to reduce the surface area. Why surface area matters? While we count atmosphere and Kármán line from 100 km, there is no zero atmosphere. It's not like the moment you cross 100 km, there is no air molecule. There is enough. How much is there? Well, ISS has to align the panels. The moment panel have two alignment. First, trace the sun. Makes sense, logical, right? You want to align to the sun, get the most energy out. Cool, awesome. But is it what happens when it goes to the sun side, which is 50% of its time? It aligns to the vector of motion. Why? So air drag is less. It's not it's not like fighter jet wing fighting to it's not that, but it is enough drag that it makes sense for them to spend energy from the limited battery to like, okay, let's align it. Otherwise, they may require to reboost every quarter year. So you cannot stay in low Earth orbit if you are very low density. You need to be very high density. And you're talking about just a foil. Just a foil, it's just a CubeSat that is like, 10. Yeah, that is surface area is so high that it's gonna fall out of low Earth orbit very quickly. And you're like, what if we put it up again? Inverse square law will make it even worse. So it has to be in low Earth orbit to even have a probability of working. And at that point in time, it will require its own propulsion and fuel. It cannot just like, I'm gonna work. Be mindful, because you have to fight the sun. You have to be like, you're fighting the sun, because again, you have to control two vectors: sun location, again from your point of view, and where the target audience is. So that's going to take a lot of fuel and propellant. Even with iron engines, it's going to take a lot, especially 10 years. He was so calm. It's like 10 years. 10 years in low Earth orbit. Damn. If it's something big, dense, like Hubble telescope, which mind you is higher altitude, it's viable. And be mindful, it does have thrusters. So those things are digestible. It's like 10 years. And then it's like, we're going to upgrade to Mark II, that you're going to have 20 years. Yeah, no. And there is another aspect. There's a lot of debris in space. No, compared to Hubble's time, now there is a lot of debris. Now, debris is like fish in the ocean. You can go in the ocean. Does not mean you're going to get bombed by basically a fish. Likelihood of that is almost zero. Here's still. Is the likelihood still zero if you are talking about a giant cruise ship? No. Cruise ships, like many fish goes bam into it. Why? Because it's size, surface area. The surface area is so huge. Same happens here. If you have a tiny satellite with, again, solar panels is jetting out, but it's inherently small footprint and is going through a debris cloud, the likelihood of impact is very low. But you have like a giant square box that is like 10 meter square in all directions. And again, that's Mark 1. They are planning for even larger one, which again, that will improve the luminance part of it. That will be turned into spaghetti very quickly. By law of physics, there is that much debris now. Again, that debris, it's so common. Debris strike on ISS. ISS is a heat map. Where does it get struck? Like, it's a heat map. You can see it. It's in Wikipedia. It's like, it's a very common. It has an armor. It has a Kevlar armor to make sure that it does not get punctured. That's how much impact happens on it. So it's going to be turned to whole. And it's like, yeah, 10 years. I'm like, yeah, no. 20 years. No, not for cheaply. And then it's like, oh, it's going to only cost $100,000. Like, huh? Electronics that can survive in high neutron environment of the high neutrino radiation environment of space, even with below vulnerability, it's not zero. You can see in ISS every video footage random have noises, speckle noises. Yeah, that's from radiation. So this whole idea that it's going to be like, we're just going to put it, it's going to work. It's like, no, this whole calculation made me lose hope in that. If they were like, high altitude weather, because again, in principle, majority of atmosphere is below you at that point, it would have made sense, but it's like, no. And again, it's not cheap. It's just raw stupid. So I do not know whether they are deliberately planning to scam, some other truck companies, or they are like, they just lost because they're actually amplifying the number based on this. Now, what about the reaction to this puppy? Well, news medias are actually showcasing it, which is very scary, because here's the deal. I have the time to actually go into that. I have the time to study it. I have to figure it out, like what happened, how it happened. Most people won't do that. Ain't nobody got time for that. And again, once you see something in news, whether you like it or not, news media is still seen as a very impactful thing. And it can affect enough people to like, hey, I would want to invest into it, which again, what we are talking about is money. It's a very dangerous thing. And again, news media has seen that, like, I know in politics, everybody is, very polarized. So there's like, either my party is right, your party is wrong, that's it. But in science, we kind of have to have a common ground. We cannot just have random people who have nothing to know about science just talking about, oh, we're going to have this plane and it's going to provide sunlight. I'm like, no. So That's the dangerous part of it. And investors have poured money into it. Now, be mindful, that does not bother me as much, simply because investors are playing dice, basically, so to say. You can look into any investment company, whatever have you. Majority of their investment does not pay off. That's like a mathematical system. It's like, yeah, you roll the dice, it works, it does not work, does not work. That's like life for them. Like, so I do not find it like, oh, it sounded good, the animation looked good, so I dumped money into it. Cool, awesome. And again, if they open the stock and it becomes a pump and dump scheme, they'll still be profitable. So that part does not bother them. But the amount of money dumped into it is like, it's kind of scary. And the hype of the marketing is enough for them to get a larger payout. That does scare me. Now, thankfully, because they use so much word salad, the reason why people are not catching on to it, because they sound real, right? Everything they are talking about is factual. And again, once you show someone prototype, again, how many people will actually sit down and think about it? It's like, wait a minute, this puppy works in 10 meters. Would this puppy work in 1 kilometer? Like, you have to stretch it. Like, you have to think it through. So inverse square law, everybody's just like ignoring it. It's like, no, that's the main thing. So that's there. Now, I am happy that it is not going to taint solar technology like solar roadway did. So that's the one good thing. So like, you can have all this. It will only piss off people who are into space, techno bro kind of scenario. People who are in solar, they're like, we have solar farm, it works, done. So it will not taint solar technology. That is what makes me happy. And the damage, financial damage that it will cause, comparatively, it will be less compared to solar roadway, hyperloop, Nikola Motors. I mean, like, these puppy burned billions of dollars. So compared to that, I do not expect them to cross few billion, maybe. So, and again, YouTube community has shown surprisingly high amount of resilience against this. More astronomers, EEVblog, and more than enough people are like, yeah, bruh, no, this is just raw stupid. If you are talking about like luminance, again, fry the whole bio ecosystem, but if you're talking about luminance, it would have made sense. But other than that, it's like, just like, nope. Inverse square law is a thing. That's the most painful thing, is the thing. So without that, the likelihood of working is low. It's like, we know for a fact that it will not work. So that's the sad part. So this was my presentation on orbit reflector. Hopefully, reflector orbits. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.